Hello from a specially adapted room in a stunning location in Vught, a picturesque town in the province of Brabant in the south part of the Netherlands. We thought it an interesting contrast in these challenging times for all of us. Today we're resuming the Brabant Innovation Days discussion. In the past, these have been live meet and greet events in places like Japan, China, Israel and the US. Today, unfortunately, we can only have a few people in the room because of Corona. So the audience watching this live or later is somewhere out there on the internet. Hello. In this hour, we're going to examine innovation technologies around the global energy transitions. I'm delighted that 5 guests are able to join us today, 5 in person, all properly socially distanced. And let's begin with our first guest, who's Scientific Director at Eindhoven Engine. Let's take a look at the video we've prepared. Europe's energy transition needs to go faster, but who are the drivers of innovation? Mobile energy specialist Martin Steinbuch explains what the Netherlands is doing and shares his preferred future for the electric car.
So we have a lead compared to the rest of Europe. Norway even has a lead compared to us. However, they did not develop a real industry around electric driving, and we did. So with the lead we have, we actually also were able to develop new industries like Fastnet, EVBox, Allego, companies developing smart chargers and fast chargers. We defined the worldwide standard for communication protocols for charging points, and that's worldwide adopted. So we lead, in fact, this technology. I think there's a whole new era coming up of polymers and polymer-based solar panels, which are far more flexible in the utilization. If you have polymers which you can shape according to your wishes, the design space explodes, and that's really great. So what we need, in fact, in Europe is really an alliance for battery development. So there's a new company in Northvolt in Sweden, and I think there should be more companies. And of course, we have our startups, Lionvolt and LightJar, but we need a European momentum for this battery technology race, because batteries are the key means for the transition of both mobility as well as energy transition. So batteries is a key thing, and I think that if you think about high-tech and high-tech systems, I think also in AI, it would be very useful if Europe works together and makes momentum there.
Martin, hello. Welcome.
Hi, nice to be here. Thank you.
Yes, in person. That's great. You've touched on some important points there in the video about challenges of storing electricity for mobile use. I understand that actually the electric car isn't new. In fact, we've got a video that has been sent in. Anna Nikhil is watching today's stream, and she sent a YouTube video saying electric cars are not new. TV host Jay Leno owns a 1909 Baker Electric.
Well, no man wanted to buy a woman's car. I mean, that was the problem with it. So consequently, electrics were relegated as women's shopping cars. But this thing went 100 miles on a charge. At the turn of the century, there were 15,000 of them in New York City. You could drive. There were charging stations all over the city.
They were popular with women because petrol cars had to be started by hand. Martin, what about electric cars in the Netherlands? When did they really start?
Very similar. 100 years ago, there were more electric cars. There were a lot of electric taxis, for instance, in Amsterdam. And my great-grandfather, he wrote a few books on automotive. He started, in fact, the first school in automotive for automotive technicians in Den Haag, and later on, his books were being used in the auto school in Apeldoorn, which is now moved to Arnhem-Nijmegen. But in those days, 100 years ago, there were more electric cars basically than fossil-fueled cars, for the reason you also mentioned or did see in the video, namely that it was too heavy for females to actually start a fossil-fueled cars. And the reason being that there was not yet invented the starting motor for a fossil-driven car. And once it was invented, you could also, with clean hands, start your fossil-fueled motor. So, and at that point in time, the electric cars went away because they were quite heavy, the range was limited, and they were relatively expensive. And now, 100 years later, I say to everybody, well, the combustion car is over. because electric cars, they have sufficient range, they are sufficient cheap, and they are sufficient lightweight and becoming lightweight. Yeah.
So when do you think we're going to reach the tipping point with more electric cars than petrol-driven cars?
Yeah, if you think about new sold cars per year, then I expect that tipping point to be in 4 or 5 years from now. So either 2024 or 2025, 2026 maybe. But I think in already 4 to 5 years, I think 50% of the new sales in the Netherlands will be battery electric, fully electric cars.
Okay, so I notice you haven't mentioned hydrogen as an energy carrier.
No.
I know
For
that
cars, it's a waste.
I don't want to turn this into a debate on hydrogen fuel cells because I just think that they're extremely silly. Hydrogen is an energy storage mechanism, it's not a source of energy. So you have to get that hydrogen from somewhere. If you get that hydrogen from water, so you're splitting H2O, the electrolysis is extremely inefficient as an energy process. If you say took a solar panel and used the energy from that solar panel to just charge a battery pack directly, compared to try to split water, take the hydrogen, dump the oxygen, compress the hydrogen to an extremely high pressure or liquefy it, and then put it in a car and run a fuel cell. It is about half the efficiency. It's terrible. So why would you do that? It makes no sense. And then hydrogen has very low density. It's a pernicious molecule, likes to get all over the place. You get metal embrittlement from hydrogen. If you get a hydrogen leak, it's an invisible gas. You can't even tell that it's leaking. But then it's extremely flammable when it does and has an invisible flame. If you're going to pick an energy storage mechanism, hydrogen is an incredibly dumb one to pick. You should just pick methane.
But why is he saying that?
He's not the only one saying that. Basically, all large OEMs of car manufacturers, they say that for passenger cars, the battery developments are being so fast that they are relatively cheap and the range will be enough. And with hydrogen, you lose a lot of energy in all the conversion steps, and it brings the price higher of the fuel itself. So driving an electric car, you can never make it cheaper than simply using a battery electric driven car, because you don't have the conversion costs nor the energy which you need to convert from green electricity into hydrogen into electricity again. In fact, you could also say if you want to drive a hydrogen car, you need 3 times as much wind turbines in the Netherlands. We don't like that, I think.
Okay, but look at this interesting international story. In March 2021, Hyzon, the US manufacturer of hydrogen fuel cell trucks, signed a joint venture with the Dutch company of Holzhausen Clean Energy to build a factory in Winschoten in the north of the Netherlands. They have a first contract to build 1,500 hydrogen-powered trucks by 2026 for a client in New Zealand, so entirely for export to the Pacific. So that's one direction. Martin, what about the battery-driven trucks?
Even for trucks, I think there is a battery electric future. And again, in the total cost price of a logistic firm utilizing trucks, it's the driver's cost and the fuel. Now the fuel is so much cheaper if you utilize electricity directly into your batteries than it ever will be with hydrogen, because you have much less usage of the primary energy.
What I was thinking of was some of the myths around the electric car.
Right.
And one of the myths is that the battery won't last all that long.
Oh yeah, that's interesting. Yeah, that is because that we all have our reference with our smartphones, and we all charge it from 0 to 100% during the night, and during the day we use it up until 0%. That means that you utilize a full cycle every day. Now, if you do that for 3 years, that's about 1,000 cycles. And then your battery is sort of maybe 20% less good or so. I don't know. We say it's end of life, but still it has 80% of its capacity, but it's getting irritating if it's empty at 9 o'clock in the evening, right? So 1,000 cycles. If you have an electric car with a range of, say, 400 kilometers, and you have 1,000 cycles, it means your car, your battery, can last for 400,000 kilometers, and even then you still have a capacity of 80% of that original 400 kilometers, right? So you have still 320 kilometers per charge, and you already have driven 400,000 kilometers, which is longer normally than your car lasts, all the mechanical parts. So there's no issue, in fact, with battery degradation for cars.
So in many cases, the battery is going to last longer than the driver.
And that's why there is a huge economy coming up and also industry developing for recycling of batteries or for a second life usage, like stationary batteries at charging stations or at your home place.
What do you mean by stationary battery? So you could take the battery out of the car and then use it, at the equivalent of an electric petrol station, as it were?
Yeah. So what you could do is to actually either at the charging station use it or at your house place. Because if your battery degradation is no longer a driver for the cost price per kilowatt hour storage, then you actually can make use of the fact that you can be cheaper in charging your battery when the electric prices are low and utilize the buffered energy in your battery when the prices are high. So I think in the future we can actually earn money with having a battery either at home or at charging stations. And it also will solve the charging problem often named by truck manufacturers, saying that we don't have the charging network for trucks, which is not true. Because if at every gasoline station you would put, say, a 2 or a 4 or 6 megawatt hour battery capacity as a stationary battery, you can deliver peak powers of a megawatt to charge a truck in, say, 30 minutes, and then charge it at a slower rate with solar or at night when the prices are lower of the kilowatt hour.
And you think that the electric cars will come in much faster than, for example, the Dutch government thinks, because they're talking about, 15%?
Yeah, so the goal of the Dutch government is 2030 to have 100% new sales in the Netherlands of battery electric cars, but they expect in 2025 only 15% battery electric, which is already achieved last year. It was 20% last year, and I think that in 2025 it will be 50%. Yeah.
Great. Well, thanks very much indeed for those comments. Please stay around. So let's switch now to another TNO research centre located on the high-tech campus in Eindhoven. Let's take a look at the video.
Many European countries have set impressive goals to make full use of solar harvesting. But to be on track, the Netherlands needs to generate 200 gigawatt peak by 2050. There's not enough space for legacy solar panels. This isn't the future. That's why Solion Solar Research in Eindhoven is leading the European Perovskite initiative with 800 researchers and company product engineers in 19 countries working on alternatives. It's time for Europe to leverage its advanced knowledge of new materials, integrating bifacial panels at the side of the road, in the windows of buildings, on dikes, inland waterways, even on the satellites monitoring climate change. If you're watching this stream either live or later and have a question about what you're seeing, send an email now to questions@BrabantInnovationDays.com. We're happy to connect you.
So if all the technology works, I think we can talk to Ron Andresen. Is that correct?
Yes, good afternoon. Can you hear me?
Perfectly, yes. So Ron is Director of Solions. Welcome to our live stream. Perhaps you can update us on how far you've got with the Perovskite Alliance.
Yes, so I'll start with the beginning. I think about 2 years ago, we tried to have an overview of what's going on in Europe in the field of perovskite PV research. And we initiated the EPKI, it's the European Perovskite Initiative, to create an overview of what's going on and to create a first European white paper on this topic. 1 year later, we started to think to bundle forces between the main PV research institutes in Europe, being Fraunhofer, CAA, call it. So we are 9, and we are progressing a first collaboration agreement between those 9 in order to bundle forces in the research field, but also come up with one proposal to the big European industries. Because we believe it will be important to have a clear grip on these new PV technologies, because PV will be embedded all over in Europe. So we have to have a very strong, let us say, influence in the supply of this new kind of PV, because it's an important asset to the community and to the society.
Because I'm curious, I mean, I thought that the manufacture of PV had all gone to Asia. So
yes, this is the case, and this is not a healthy situation, as PV will become a very important asset to the new European society. If you look to the Green Deal, that's one. And secondly, current PV panels, they do not fit very well in very crowded areas, like, for instance, the Netherlands. So you have to go to better solutions where you can have nicely integrated PV, where you don't see it anymore that there's PV involved. And with the current standard panels, that is not feasible. So you have to go to another approach, and that's why thin film PV, as we call it, it has much more, let us say, opportunities to do this much better.
And how far have you got? I mean, how efficient are the cells at the moment?
So if you look to perovskite only, the world record today, it's a lab scale. It's like 25.5%. It's like silicon you can do, the best lab cell. On the scaling, the best large area module produced so far was done by Panasonic, and it reached already slightly over 70%, which is coming in the average PV efficiency of today, if you buy a module.
And when we were talking to Jan van Hest, he was talking about sort of self-cleaning. He talked about organic cells. So is this a competitor or what?
No, I think if you look to thin film photovoltaics, you can have several semiconductors inside. And we are now working on the perovskite-based semiconductor, where we observe a lot of industrial traction. But if we can have improved performance or improved environmental impact, things like that, with another absorber, we will definitely go for that, because the basics stay the same. You need two electrodes, you need some contact layers, and you need a semiconductor inside. And whatever the material is, we don't mind. Today we focus on the perovskite.
Okay, I'd like to bring in a question actually that's come in specifically for you at Soliance. So let's roll the video.
Well, what I would like to ask Soliance is if the future of solar panels from a mondial perspective is that they will be mainly used around the Mediterranean, because you get a lower kilowatt hour price there because you have more solar hours. And how are you going to transport that energy to the place where you use it? So mainly Northwest Europe. Are you going to do that in the form of electrons or in the form of, for example, molecules? Personally, I think the latter, because the infrastructural costs will be way lower than when you need to make a transmission line all the way from the south of Spain to, for example, the Netherlands.
I understand your question, but our vision and strategy is different. We want to harvest electricity at the locations where it's needed. So we want to avoid as much as possible long way transport of the electricity. So that's why we would like to wrap all buildings into PV. We would like to wrap all the vehicles into PV. We would like to wrap the roads, the infrastructure. We would like to wrap that in PV. Without that, you can see it. And this means that you will have electricity harvest going on the locations where you need it.
And is there legislation coming that buildings have to be energy positive, and by when?
It's already there. So now we have already implemented the near zero energy buildings, and it will go to a plus in the future. So you will need a lot of additional energy harvesting devices inside, not only solar, but probably also heat and whatever it is. Yeah.
And are you looking to other European companies to expand your alliance? I noticed there's quite a lot of work going on in Poland, for instance, where they're doing trials by putting the panels in the sides of buildings.
Yes, for sure. So we collaborate with this company, of course. We know all the players here. And we want to bring them further to a more mature and a more efficient and a lower cost product at the end.
So finally, what's your preferred future for solar certainly for the PV industry.
Solar electricity everywhere. That's our mission.
Ron, thanks very much indeed for joining us today on the Brabant Innovation Days. Now, let's return to the subject of energy storage. The whole centre has been working on what they call thin film batteries. Let's have a look at the video.
The Holst Centre in Eindhoven has been busy with energy storage questions for several years. They are the experts in developing thin film batteries as a major contribution to the Netherlands' energy transition. As we enter the new dawn of electric mobility, the Holst Centre is working on solutions that offer both high capacity as well as very fast charging. And the spin-off companies with thin film technology are starting to emerge. Let's explore further.
Tom, please explain. What have you got there?
Yes. So let me start with a battery. Everybody recognizes this is an automotive battery, but it of course resembles the pen light batteries everybody knows. It's a cylindrical cell. And inside is a battery foil wrapped in a cylindrical format. These batteries is what we call thick film batteries, where the layers, the anode, the cathode, the separator, and electrolyte, are typically in the order of a tenth of a millimeter, 100 microns of a couple of 100 microns. What we are working on is what we call a thin film battery, and I'll explain. These thick film have a lot of, they're common good now. But it's not the ideal battery yet. I think people are still sometimes worried about safety. I think everybody remembers the Samsung Galaxy 7 debacle in the planes, or the visions of Tesla's burning. Everybody knows that the driving range, it is adequate, but you would love to drive 800 kilometers. And be honest, the charging time is still 30 minutes is way too long if you want to drive to south of France. So if you can do that in the same time you now pump gasoline, that would be perfect. Yeah. So we're working actually in technology who can do that. And the base for us is a thin film battery. And a thin film battery has several advantages. It's already there. It's used in smart cars and in pacemakers. And it has some really nice advantages. Because it's thin film, the requirements on the electrolyte are not so severe, so you can use a solid state. So it's an all solid state device, and by that also very safe. It also has advantage because it's very thin. The diffusion of lithium can be very fast, and your charging and discharging is also very fast. A few minutes and you're done. Of course, it has a disadvantage. It's a thin film, so the storage capacity of lithium in a thin film is of course a lot less than in a thick film. And so if you're working with layers which are 1,000 times thinner, the capacity is 1,000 times lower. So how to circumvent that? And that's what I want to show here. Our starting point is a thin film battery, like here, the thin layers, but employ it on a gigantic 3D surface. And that's the basic principle. Increase the surface area by a factor of 1,000, and then you're done. That's the principle. And this is a mock-up, extremely scaled, and you have to think these are 200 microns long pillars with a few microns in diameter. A gigantic surface area, and then you apply, like you show here, a thin film battery on top of that. This is the basic principle. In a mock-up, it looks very easy. But the difficulty is you have to, of course, uniformly make these thin films on this 3D surface. And luckily in Eindhoven we have a technology developed with companies like Saltec and VDL called spatial atomic layer deposition, where atom by atom we can build these layers on top of these surfaces. It's a technology from the semiconductor industry, but with our partner companies, we scale that up that we can apply these ALD layers with the speed which is about 100 to 1,000 times faster. So you can really with a cost-efficient process, make these batteries. And that's actually the pitch of our 3D solid-state battery concept.
And where will these batteries be used? Because are you going to start with cars? Are you going to start with, for example, the health patch?
This is a radically different concept than from batteries now. Nowadays, it's particle-based batteries. You slurry coat them on top of each other, and then you're done. To produce this, you need a completely new production process, which is not there yet. So we would love to make this for cars, but we don't have the volume yet to do that. And so we start with the pilot line in the next couple of years, and then the volume coming out of that is more suitable for things like wearables, where you don't need that many batteries. You have to think of just one Tesla already has 7,000 of these things in a car. So before we go to volume productions, we have to go through all the steps. But we hope to end up in a car. That's of course the ambition.
And will it be better than what Tesla is doing?
Much better.
Of course, you'd say that. But so when are you going to build a factory?
So we're now building what we call a pre-pilot line to showcase on this kind of samples in pouch cells that this works, that this really in reality works. Then we go to a pilot line where we really want to supply battery layers, battery cells for wearable products, and then you go to the bigger factories. So it's a three-step approach for us.
And what about what Martin was saying about a battery alliance? Do you think that's going to happen?
Yes, so this is a completely new production process. So you can imagine that we're talking to all companies in Europe and the Netherlands to set this up. And Lionvolt is then the company who's going to exploit it, but you got a lot of partner companies to make it happen.
There are also competitors worldwide, yeah? QuantumScape in the US, partly being owned by VW, and also in Korea. Are you not slow enough by saying we do it step by step via the consumer market?
We don't think so, because you don't go from a lab setting to a gigafactory in one go. That doesn't make sense.
No?
No.
Tesla did.
Not completely. Yeah, I think Tesla. The batteries came from Panasonic, and they were already working on that.
If you would have enough money, what would you do actually?
I would still do the steps, but
faster.
But much faster.
Okay. I think it should be.
We had this discussion.
I think it should be done faster.
I can only agree.
I think it's unique technology, but the market really needs it.
Yeah. I can only agree. Okay. But QuantumScape, as an example, it's already 10 years old, and they didn't do anything yet. Yeah. So we're just starting a year. We do the pre-pilot, but I agree, completely agree. The market is crying
and the technology QuantumScape has, and also I think LG is the other one, or what QuantumScape has, is it similar or comparable, or is it different?
No, they really, as far as we know, they're not that open. Is really on a solid state electrolyte concept for plugging in standard batteries. Yeah. Ours is overhauling the complete production process.
Right. It's really thin film. They don't have the thin film thing. No. Okay.
So let's go to our final guest today, who's actually sitting with us. Let's look at the video.
At the Brightlands Material Centre in Geleen, they're specialised in 3D printing of all kinds of fibres, glass, carbon, natural, all impregnated with thermoplastics. You can make personalised bikes, auto parts and more. But why should we care?
Did you know that mobility and transport are the second largest cause for CO2 emissions in Europe? That of course includes aeroplanes, but also cars and transport vehicles. What can we do to reduce those emissions? We can use lighter materials. We can make the vehicles lighter. So for example, if we look at this bracket from an airplane, typically made from metal, relatively heavy. If I 3D print this with a composite, I can save weight. But if I 3D print, I can also change its shape and reduce further weight. And I can go even further. I can optimize the shape and make something that is 20 to 30% in weight from the original bracket. If you do that for all airplanes and for the whole aerospace sector and for our cars and transport vehicles, we can have a major impact on the CO2 emissions of the mobility and the transport sector.
So what have you got there?
I actually brought the brackets you just saw in the video, and maybe I should shortly explain what we're trying to do here, because everybody probably knows 3D printing or additive manufacturing. It's a known technology, especially also with consumers. And what we're doing now is making the step to the industry as well. And what we are doing is helping to develop a new 3D printing technology in which we combine continuous fibers, carbon fibers, glass fibers, which basically bring strength to parts, and we glue them, so to say, together with thermoplastic polymers. And we do that by 3D printing process, which gives us a lot of flexibility in where we are actually putting the individual fibers. This combination of fibers and thermoplastics we call a composite, and composites are existing materials today. We use them a lot to make lightweight ships and cars and so on. But what we can't do with composites today is create very complex shapes like this one. This is a bracket of a bike. We are making in a project a 100% limber bike. And in that project, we want to make a racing bike personalized to the person. So if you have somebody that has very long arms and short legs, you want the frame to be a little bit longer and a little bit shorter. So you adjust the tubes, that's easy to do, but then you also need to change the brackets because the angles between the tubes are different. So you need a unique set of connecting points, lugs they are called, for that bike, for that person, just one set. So that screams for additive manufacturing because it's a very flexible technology. You can easily make simple parts, but you can also make these complex shapes. And that's what we're trying to do. And this complex shape making helps us to reduce the weight, because if this bracket made from metal, we change it into thermoplastic composites, makes it lighter, but then you can fully optimize that to the part, and you create bird bone type of structures, and you put your fibers only there where you really need them to give the strength and the head that you need to have in a particular part. So it creates lightweighting and thus fuel saving or range extension. Use the battery that you have and extend the range that you can do with it by saving the weight in material, but also in shape.
And can you measure the sort of lifetime of the material? I say that because, you know, in aeroplanes, they're building planes of all new materials, and I'm guessing that nobody really knows how long that's going to last before the equivalent of metal fatigue sets in.
Yes, and we don't have metal fatigue, of course, but there are other ways that things can deteriorate. And so what we're doing is, of course, our scientists we're trying to understand. We're using the polymer knowledge that we have, and we're trying to predict the fatigue properties and what that's happening. So this is a modeling and testing type of activity that is going on. So that we don't see big problems there. That's just something that needs to happen. The other point that you're also touching on is then what do you do with this when the end of life is there? So now your airplane, or think about windmills. We have a lot of windmill blades, and what are you going to do with them when they're done? I saw some bicycle hallways made of it, but you can only have, how many bicycle hallways do you need? Yeah. So we need to recycle those. And composites today, they are made from thermoset composites. So there's a difference. And thermosets you cannot reuse. The only thing you can do is mill them down, burn them, and put them in concrete and use them. These are thermoplastic composites. This is different. If you heat those up to certain temperatures, they will melt. And then basically you can reuse the thermoplastic compound out of here, and you can reuse the carbon fibers out of here. So there's a recycling advantage that this thermoplastic composites can also bring.
Can you build sensors into them?
Yes, that's another invention, or that's not really our invention, because if you use continuous carbon fibers, they change their electrical resistance when you deform them in the part. And that means that any part that I use, for example, this bicycle bracket, and I have a bicycle, and what I would love to have is a power meter. These are quite expensive, to be honest. But in this bracket, you could measure the deformation that's going on in the bracket because of this continuous carbon fiber, and monitor that and translate that in the power that I'm actually exerting onto the frame. And that's interesting, nice to have for a bike. But if you think about, again, the windmill, a blade, or any other type of transportation, you could start using that for structural health monitoring. It could help you to make a clever decision. Okay, this part needs maintenance because it's going to break in 3 months from now, or this part, it still can go for another year. So you just replace the parts when they're actually broken and not before. Again, a sustainability advantage.
So, as TNO, where do you start and where do you stop in the process of development?
So this is something, and what we try to do, we try to help the industry to innovate. So this is something that is really new. So we saw this happening, and we think that has a lot of potential. And what we're trying to do and help the industry is to develop this technology and make it closer to showing a feasible demonstrator. Show them that these parts work. They need to be strong enough. They need to be production feasible, so that the printers need to grow, the process needs to grow. We need certification of those materials, standardization. So all that work we are more or less doing. And then we're always looking for new use cases, so examples to work on. We love industry to work with us already, so it really helps us to direct what we need to do. And then when we get to the demonstrator point, we hand over.
So are there particular user cases that you're looking for?
So in particular, at this point, we are looking at the aerospace and the mobility area because of the energy transition, the sustainability aspects, and also the lightweighting. So aerospace is very important to us. I call mobility, automotive. We don't believe yet that standard cars with 100,000 cars per year can be done by 3D printing, because those are very high volumes. But there are lots and lots of small series spare parts, customized cars, electrical vehicles, and things like that, where this could be of advantage. So those kind of applications.
I'm sure, especially the old vintage cars, love that.
Or the car that's on the face of their book.
The Lightyear, you mean?
Yes.
They work together with you? Could be.
Could be.
Could be. Well, they are making a small series for the first one, and they are really eager to push down the weight. This car will be the.
Maybe you can explain a bit about Lightyear, because
yeah. So
some people
Lightyear came out of our solar team, Eindhoven student team, which did win in 2013 the World Solar Challenge for the cruiser class. That's the first class in the Solar Challenge in Australia for families. In fact, they drove with their car 1,500 kilometers with 4 people inside without charging. 1,500 kilometers on one charge, without having a huge amount of batteries, of course, and good speed. So, and it's now a startup led by Lex Hoefsloot at the Automotive Campus in Helmond. 150 people. They just finished close to round of $49 million. So really great. They go to the next phase. They're preparing, building a series, I think a few hundred series of their Lightyear 1, as it's called. And you can see it also contains solar cells, which are deformable. So there's also a link with the previous speaker. By the way, it's on the cover of the book of me and Carlo van der Weijer. Every week we write in the Financieel Dagblad, the financial news magazine of the Netherlands, on the future of mobility. And all those columns, 70 of them, are collected in this book. Dutch version, English version. We love to think about every week what we should pick as a new item. And we talk about bicycles, electric flying for the future, drones for logistics, but also for passenger mobility. Of course, electric cars, trucks, even some robotics is in. So we love to dig every time in a subject. And just now I finished the column, I just sent it in this morning, on solar fuels. So how to make synthetic kerosene for the future, because the long distance traveling with air and also with container ships from China, as an example, there's not a solution yet with battery electric. There's no solution yet with hydrogen, because also hydrogen does not contain enough energy per volume or per kilogram. But if you can make a solar fuel, so you use electricity from wind or sun and you generate hydrogen using electrolysis, and you take CO2 via, for instance, direct air capture. We have a startup on that, Carbion, in our region. So if you have CO2 from the air, you have H2, hydrogen, you can in fact make kerosene in a standard chemical process. Now this whole chain, of course, takes energy and cost. Energy is not the key thing, because already now, at this very moment, solar energy in Saudi Arabia is only $1 cent per kilowatt hour. The cost price of solar energy in the Middle East is only 1 cent per kilowatt hour. So the price of the electricity is not the issue. The issue is the cost of the electrolyzer and the cost of CO2 capture. So if we can bring down those two components, the capex, the capital cost, then actually it becomes feasible business-wise to make, say, artificial kerosene.
I've seen also some experiments that people have been using formic acid.
Yeah, so there are various forms in which you can liquefy and store energy, but the most compact one is kerosene. And you can do ammoniac, and there are various options and acids, but they are all not as efficient as kerosene. So that's the best one, and you can actually use it in the current day airplanes. However, it's still very costly. At this moment, if you make artificial kerosene, it takes about €7 per liter cost price, not sales price, cost price. So that's far too expensive for now, but we expect in, say, 10 to 20 years, it could go down with a factor 7, but we need to develop this electrolyzer, and we need to develop this direct air capture of CO2. And if we can do that, if we can bring both of them, say, a factor 5 down in cost price of the capital, then we have solved the energy problem for air traffic and for ships on long distances. Very interesting.
And talking about aeroplanes that you mentioned there, I saw fascinating articles indicating that if they could make aeroplanes run on batteries, of course that would revitalize the regional airports, like Eindhoven.
Yeah, so already on the shorter term, you can actually think about smaller airplanes with less people flying on battery electric. And the same as for heavy-duty trucks, it is very cheap to run it because the energy usage is more efficient. Solar energy and wind energy is very cheap relative to kerosene, even to standard kerosene nowadays. So you can really have a low cost of the transport itself. And henceforth, if you think about, say, a range of 500 kilometers with airplanes of, say, 20 people max, run fully on battery electric, you could go from city to city in a much faster way and far more better for the environment than taking a train or a gasoline car or even an electric car with one person. We proved, we calculated, it is better for the environment to go to sit with a number of people in an electric aircraft from Eindhoven to, say, Hamburg than to take the electric car.
Amazing stories. Now, as well as storing electricity, a new company in Brabant, connected to the Eindhoven engine, is busy working out how we can make better use of huge amounts of wasted heat. Let's have a look at the video.
If we want a future in which all energy is generated sustainably, then we need to find ways of dealing with the peaks and troughs of energy demand. Of course, we need to store electricity, but it's also useful if we can store heat in a lossless way. In 2020, a spin-out company was formed to take research by Eindhoven University of Technology and TNO to develop a heat storage battery small enough to be used in the home. The patented invention uses a thermochemical principle using a salt hydrate and water. So how does that work? And why has it taken 10 years to develop?
Water and salt, you put them together, then heat is released. And the nice thing is you can also reverse that process. So by heating up your new salt crystals, you can separate water once again from the salt and store it separately. And as long as you are not putting those two together, the energy that you've used to separate those components is stored. And it sounds very easy, but just imagine a salt crystal and you have water. So water is binding to the crystal. What happens is a new crystal is formed, but also the volume is increasing. And if you're heating it up once again to separate your water from the crystal, it's shrinking again. So that process is going on. And you can imagine that is introducing a kind of mechanical load on your system. So most salts are falling apart or are making new conglomerates. And that's not a nice thing if you would like to build a rechargeable battery. So two main characteristics of a thermochemical reaction. First one, it's loss-free, and the second one, it has a relatively high energy density. And the practical implication is that you can make a battery very, very small.
They've now succeeded to make a salt that is stable for a large number of cycles. The system turns out to be 10 times cheaper than conventional solutions using electricity. So where does the Eindhoven engine come in?
The Eindhoven engine project is filling in a crucial and remaining gap in the other projects. And why it's crucial? It's focusing on determining the state of charge of our battery. And that's where Eindhoven engine was creating added value, because now we have also Fontis on board with crucial expertise in the interaction that we need from the heat battery with the peripheral systems. So not only developing sensor technology, but also in terms of bringing your data to the cloud and communication to the outer world.
Right, let's open up the discussion now, because we've had some interesting feedback that's come in. One question, is ASML participating in the thin film battery manufacturing? I would imagine they have some relevant expertise.
Not yet.
Okay, clear answer.
No, we're talking to ASML, and I think that their expertise becomes very relevant when you go to upscaling. And maybe a nice thing about this battery, if people in the semiconductor industry can see it, it has a kind of similar scaling as in semiconductor. Because what you're doing here, on a square centimeter, about a billion individual micro nanocells. And you can increase the height, you can increase the density, and in that way you can have a kind of scaling law for batteries. Also, the nanometer manufacturing is, of course, something in the ballpark of ASML. So yes, hopefully we can involve them in the future.
Can I also add my comment here?
Of course.
I hope not.
Okay.
I hope not, because I think all the suppliers in our region are already very capable of doing nano and micro scale manufacturing, and we all hope to be a little bit less dependent on ASML. So in that sense, I hope that this will be a BSML. And the Lionvolt company, which came out of TNO Holst, I hope it will become a huge player and giving a lot of assignments to our local manufacturing industry. But of course, we like the people from ASML, and they can always use their knowledge to help Lionvolt to become bigger.
Well, they can also move from ASML to Lionvolt. Exactly. And that's also a possibility,
yes.
Maarten.
Yes.
Another question. Also to Tom van Mol, what do you think when do you think solid-state batteries will replace NMC batteries?
Okay, so well, not. So with solid-state battery, what most companies are doing is replacing the electrolyte with a solid-state electrolyte. Doesn't mean that the cathode, the NMC cathode, has to be replaced, maybe adjusted. When the prognosis there vary a lot. There are companies who just don't believe it will ever happen on a thick scale to manage a solid-state electrolyte which has the performance you need, and others project 2025 or 2030. So I find it difficult to predict there. I think our approach, a thin film approach, where the specifications on the electrolyte are a lot less, and it's already there. There are completely solid state are there, and you can still use NMC as a cathode. So,
okay, answer's clear. Another question: what do you think about Tesla's million-mile lifetime cycle battery, and compared to the advantages of your own technology, and when it could be implemented?
So I think Maarten already explained that a million mile is almost there. That's not the issue. And I think a thin film battery even lasts longer, much longer. If you look at current thin film batteries, they go on forever. So that's not the issue. And when our battery concept of Lionvolt BV will replace other batteries, I can only agree with Maarten. If you can put our shoulders on it, then the sooner the better.
And what you mentioned, I think the charging times is the big benefit. So the battery degradation is not the issue. And again, million miles is already very close. It's 2,000 cycles with 500 miles range. So, however, if Lionvolt is successful with this battery, then also for heavy-duty trucks, the charging times will be so low for, say, 1,000 kilowatt-hour battery. You can charge in 20 minutes then, or so. That's even half only of the required resting time for the driver after 4 hours of driving. So then we are very close in really clean mobility. No.
Okay, another question. Konya is making lightweight electrically conductive fibers of CNTs, having conductivity 10 to 40 times higher than usual carbon fibers. You could place sensors in your 3D structures, no corrosion, no problems with brittleness. Would that be interesting for you?
Yes, so carbon nanotubes, we know, and you could also use fiberglass type of sensors as well. So, and with 3D printing, the advantage that it gives is that you can very precisely place the sensor inside of your part, so not on the outside, but really in some kind of curvature where you need it. So, so yes, that is an opportunity for sure. The elegant solution that we have here is that we're using this carbon fiber to give strength. And by the way, you can also use it as a sensor. So it's a secondary function that you get for free, basically. But those options are also being looked at, yeah, for sure.
Martin, I'd like to talk to you about innovation in general.
Yeah, I'm happy that you start with the subject. I was looking to the video of Ivo Aldan about the heat battery. And luckily he mentioned, indeed, it's also an Eindhoven engine project. And there we want to accelerate innovation. And like the heat battery project, which could be very successful, but it's very still early in the research phase now. But the good thing about the Eindhoven engine, we try to really accelerate innovation by going faster through those technology readiness levels, as we call it. And together with Ivo Aldan, we are just firing a lot of questions and insights and providing him with a network, both on technology, but also on the business side. So how to really increase the going through the cycles of the technology readiness levels towards the business and definition of the business, how to access the market and things like that. So the Eindhoven engine is the place where we really in the Brainport region try to accelerate innovation.
It's essential for that battery to know how much charge is left, otherwise...
Yeah, so the specific Eindhoven project is about the sensor technique and also seeing the study to look what are the best starting business opportunities, the low-hanging fruit to start with, the application. So sensor technology, AI, but also systems and control thinking, how to place the heat battery into an energy flow of a house or an office building. But on top of that, we try to also make those crossovers to other projects and to our network and to provide also to the team of Ivo to help him with the business development and to help him to make it faster to the market. In that sense, I would have liked that Lionvolt is also part of the Eindhoven engine, because I think we could help them also a little bit in going faster to the market with solid-state batteries. But
working on it.
Yeah, that's good.
It's working on it.
Okay, that's good.
And are you also interested in projects from other parts of Europe taking part in the Eindhoven engine, or is it mainly regional at the moment?
Yeah, there should be work being done either at knowledge institutes or with companies in our region. But partnerships with others is welcomed. It's possible, yes. And we have now, at the moment, we have 15 projects in the Eindhoven engine, together with the knowledge partners, TU Eindhoven, Fontis and TNO, and with various startup, scale-up or companies, bigger companies. We have currently an open call. We have a call running. We got a lot of interest from parties from the market, and we hope to pick 4 to 6 new projects to add to our Eindhoven Engine Club. Yeah.
And finally, if you were to advise a startup company, what's the fastest way to accelerate to a market, and also to take an idea and make it something that can be manufactured as soon as possible?
Yeah, the most important, I think, especially in our region, where you see that the seeds are often coming from really technology-focused people. The most important is that you open up for other people with other minds and other mindsets and other experiences, like market, business, financial input. And we have a lot of activities running in our region to support you as a startup, like The Gate. The Gate is a new initiative for the province of Brabant and the BOM and our region to really accelerate and help starters. We have also High-Tech Excel at the High-Tech campus. We also have the Eindhoven Engine, where we pick up the already established startups to help them further. So seek for help. And be open for other-minded people, because there is a big gap potentially between your prototype at a knowledge institute and your industrialized version. And you need help for that also to think, okay, how do I focus and what to focus? And also in trying to get money. Everybody states always there is enough money. That's nice, but the money is not available easily. So there's a difference between availability of money and the term there is enough money. Yeah.
Just mention about the gate there, because you hear all these phrases about triple helix and maybe even more. That's basically government, industry, and research working together. Yeah. But where's the public?
Yeah, so we call that the quadruple helix. So to take the citizen into account, that's really. I think even if you talk about the triple helix, the customer is always in sight, always, because every startup is thinking, okay, what is the customer value? So I think the customer is, and you and me and we as we sit, we are also customers. So in some sense, it was always already the quadruple helix. But to give a little bit more attention to the societal needs, to the people, it's also important to give emphasis on that. And we have a few projects, we call it our own projects within Eindhoven Engine. For instance, to think about how to help with high-tech, how to help the people who cannot read. Because 10% of the Netherlands having problem with reading. And also the people who are having problems with digitization. That's about 30% of the Dutch people have problems in utilizing digital means. So how could we help them by providing the smartest minds with this problem statement? And now we are having internally the Eindhoven Engine discussions about how to make projects for this group of inclusiveness problems, as I would call it.
So if you were to advise researchers that just make a brilliant breakthrough that's going to take, 10 years to come to market, what's the best way of doing that?
Yeah, it depends on the researcher. So some researchers really like to stay within their own small area, and that's fine. But some researchers like to open up and think a little bit ahead. And to those researchers, I often nowadays ask the question, okay, suppose that your research is finished. Say it will take 10 years. Suppose it's finished. What kind of startups could there have been designed or started based on your research results? So try to think 10 years ahead. What could be the result? Either for large companies, or could it be in the form of a startup? Now, if you have defined, say, 10 ideas for startups at the end of your study after 10 years, and the same is for Richard with his 3D printing of fiber enforced materials. Think 10 years ahead. Think about, brainstorm about what kind of startups. Take 2 of them, which you think are the most low-hanging fruit ones, and start already now thinking about defining those startups. Why wait?
Brilliant. Thank you very much to all our guests around the table. That concludes this session on the energy transition. Thanks to all the guests, both here and, of course, online. We can't hope to be comprehensive in an hour, but we can start a conversation. And we've had lots of reaction that's come in. As I said, drop us an email, send us suggestions, because there's more to come from the Brabant Innovation Days, especially when we're allowed to travel. Thank you, and goodbye for now.